Let's take a look at this example. This time we are going to start our proof from the right side. Now, please notice that in the numerator we have the sum of the cubes. Okay? Let me remind you the formula. The formula says a cube plus b cube is equal a plus b, and I have a squared minus ab plus b squared. This is the formula for the sum of the cubes, and this is basically what we're going to apply to the numerator, where this is going to be my a and cosine cube alpha is going to be my b. Let me copy down the right side first. I have sine cube alpha plus cosine cube alpha over sine alpha plus cosine alpha. As I said, we're supposed to apply this formula to the numerator. And we have sine alpha plus cosine alpha times sine square alpha minus sine alpha cosine alpha plus cosine square alpha over, we have sine alpha plus cosine alpha. Please notice that in the numerator we have multiplication, and we have sine alpha plus cosine alpha, sine alpha plus cosine alpha. We have exactly the same terms in the numerator and denominator. That's why we can cancel them out. And what we have got? We have sine square alpha minus sine alpha cosine alpha plus cosine square alpha. Now, we have sine square alpha plus cosine square alpha. We're supposed to use the Pythagorean relation. Sine square alpha plus cosine square alpha is equal 1. That's why I'm going to write 1 minus sine alpha cosine alpha. Now let's take a look at what we have got. We have 1 minus sine alpha times cosine alpha. On the left side we have sine 2 alpha over 2. So what we're supposed to do next? We're supposed to remember the formula for the sine of twice an angle. Sine 2 alpha is equal to sine alpha cosine alpha. Now, we have sine alpha cosine alpha. We have sine alpha cosine alpha. In order to get sine alpha cosine alpha only, I'm supposed to divide both sides of this formula by 2. This 2 and this 2 will cancel out, and I have sine alpha cosine alpha is equal sine 2 alpha over 2. So I can rewrite sine alpha times cosine alpha as 1 minus sine 2 alpha over 2. Now we're supposed to look at the original identity. Left side is identical to the expression which we got after the simplification, we can say. So it means that the left side is equal to the right side.